Today we will learn about the functional interface. So I'll create the interface as a test here, and I will make this interface as a functional interface. As per rule of functional interface should have exactly one abstract method. So I'll create the method here, public string test. So now this is the functional interface. But you can also mark this interface with the functional interface annotation. But it is not a mandatory, right? But it is a good practice if you can mark a interface with functional interface annotation. In future, someone want to add one more method inside existing interface, like I added here test1. So it will give a compile time error. So it will not allow to add one more abstract method inside the interface. But if you not marked interface as a functional annotations, it will allow, and it will break your logic based on this method, and now it is a normal interface. So it is good if you can mark the interface with functional interface annotation. So here I'll mark this. Okay, now I'll just for example create the default method because there is no limit. I just created default method display here. Okay, hey, I am here. Okay, so there is no issue with the default or static method you can create, right? Okay, fine. Now we will learn about the use of functional interface. So simply I'll say here functional interface is a return type of lambdas, and it is also instantiated by the lambdas. So we will check with the practical. So I'll create the class for testing, test interface. So here for testing I'll create a main method. Before testing it, I'll give a background knowledge about return type. What is exactly mean of return type here? If I'm getting an integer value as a return, then I need to create the integer value for holding that. If I'm getting a return value as a string, then I need to create the return type variable as a string. Same if I am getting return value as a custom class, then I need to create the custom class type reference variable. Okay. For example, int I equals to 10 and string as equals to abc. Same for lambdas. So lambdas is a return type of functional interface, right? So I'll use here test functional interface test. I use test type of reference variable for holding the value, and I use lambdas here. Okay, soft code. So this is the return type test functional interface return type of this lambdas, and this is also instantiated. This is also instantiate the functional interface, right? So here we can simply print, or we can call the method of a functional interface. So here I'll call test is equal to test. Okay, I'll run this program. You can see subcoder this value, right? Okay, I'll run again. Okay, this one. And you can also call default or static method with this variable. So test dot simply display I'll call here. Okay, you can see output. So I hope now you got it. What is the return type mean and what is the mean of instantiation? Now I'll tell you why actually I added open and close bracket, right, without any passing argument and anything. So it is depend on your abstract method. Suppose in abstract method having the parameter, you need to pass the parameter. Suppose I have suppose int I, then it will give a error. So here you need to pass as a parameter integer here. So you can pass as a 20. Now it will work. I mean not directly integer value. You can just pass like int x, and when if you will call this method, you can pass 20 here, right? And you can want to perform operations on that, so you can just suppose print x here. So it now in this case it will return with addition of 20, right? So you can see 20, right? This is the 20. So this is also based on your abstract method passing the parameter. So as per your functionality you can add the parameter. Then we will check. Suppose we did not mark this annotations as a functional interface and someone added one more abstract method. I'll say here test2. So there is no issues with the interface, but yeah, lambdas is not able to understand which exactly method I will be call, right? Sure, your functionality not work. That is the reason functional interface should have only one abstract method, because lambda cannot understand right now. This code will not compile. Okay, even you will say parameter issue, there is no parameter even issue. Okay, so it code will not compile because lambda cannot understand. So that's why it is a rule of functional interface. You should make one method only as an abstract inside the functional interface, and also mark interface with functional interface annotation. So it will not allow to add a different method as an abstract method in future. So that is the good practice. So in a JDK8, a lot of functional interface are added. So just we will check that that common interface. So these are the functional interface provided by the Java 8. Not these, but yeah, a lot of interfaces are provided by the JDK8. But yeah, these are the very popular interface like consumer, supplier, function, and predicate. You can see the use of these interface inside the Stream API, and we'll also make the video on the same. So here I can say use of functional interface. Like it will one more like it will also avoid anonymous class type of implementation. So we can reduce a boilerplate kind of code from our code. Okay, so these are the advantages of a functional interface. So thanks for watching this video. We will create the next video on Stream API and we will learn about these inbuilt functional interface. Thank you.